Hello everyone. In the next several videos, we will cover important prerequisite materials for the Advanced Engineering Analysis course. We will go over important concepts from algebra and calculus courses, and we will solve examples to demonstrate these concepts or show applications of these concepts. In this video, we will discuss exponential function and also cover the properties of exponents with examples. Exponential function is defined as a to the power b. Here, a is called the base and b is the exponent. Now let's cover several of the important properties of exponents. In this discussion, I will use symbols a, b, x, and y. Here, assume that a and b are positive real numbers, and x and y are real numbers in this discussion on properties of exponents. So as the first property, a to the power 0 is equal to 1. So any positive real number a, if we take the power of this positive number, real number a, to power 0, it will be equal to 1. So examples are 2 to the power 0 is equal to 1. 1 to the power 0 is equal to also 1. And 10 to the power 0 is also equal to 1. And this goes on. As the second property, a to the power x multiplied by a to the power y is equal to a to the power x plus y. Here, important thing is the bases of these exponential functions are identical, which is a here. So if we have same base for the exponential functions, and if the exponential functions are multiplied, we can simply sum the exponents x and y. So we have the expression a to the power x plus y. Examples for this, consider we have a squared multiplied by a to the power 3. So bases are the same, which is a. So we can write it as a to the power 2 plus 3. So these are the summation of the two exponents, 2 and 3. And we know that 2 plus 3 is 5. So this is equal to a to the power 5. We can, instead of using a variable such as a, let's use a constant value, let's say 3. So 3 to the power 2 times 3 to the power 3 is equal to 3 to the power 2 plus 3, which is 3 to the power 5. Now let's go to the third properties of exponents. A to the power x to the power y is equal to a to the power x times y. Okay, so if we take the power, if we take the exponential function a to the power x, and if we take the power of y, it will be equal to the exponential function a to the power x times y. As an example, consider 5 to the power x and take the square of this exponential function, 5 to the power x. This is equal to 5 to the power 2x. Or we can show this also, we know that just as an alternative way, 5 to the power x and square of this expression, 5 to the power x, means that it is 5 to the power x times 5 to the power x. This is square, right? So it's multiplication of the exponential function with itself. So we know from the second property, we have the same base. So we can write this term on the left as 5, the common base, to the power summation of the exponents, which are x and x. So x plus x, which is equal to 5 to the power 2x. If we have let's say 5 to the power 3 to the power 2, then it is equal to 5 to the power 2 times 3, which is 6, 5 to the power 6. Now, as the fourth important property of exponents, if we have a times b to the power x in this form, this is equal to a to the power x times b to the power x. So the power x will operate on both of the terms a and b in the parentheses. So now let's consider as an example 2 times 3 to the power 2. So we can operate the power 2 on both terms, which is 2 to the power 2 times 3 to the power 2. Just to show that this equality holds, 2 to the power 3 is 6, and we take the square of it. So the left side of this equality is 6 squared, which is equal to 2 to the power 2 times 3 to the power 2. We know that 2 to the power 2 is 4. 3 to the power 2 is 9, so 4 times 9. Then 6 squared equals to 36. 4 times 9 is equal to 36, and they are identical. All right. So as the fifth property, a to the negative x is equal to 1 over a to the x. So if we have a negative exponent, we can write it as 1 over the exponential function raised to the positive exponent. So this negative term is used to put the exponential function in the denominator with a positive exponent. To demonstrate this, as an example, consider 5 to the negative 2, which is equal to 1 over 5 to the power 2, which we can also show it in another form. Consider 5 to the negative 2 is equal to 5 to the power 2 to the power negative 1. This is from property 3. So this is equal to, from property 5, we have 1 over 5 square. All right. We can also write 1 over 2 to the negative 3 is equal to 2 to the negative 1 to the power negative 3. So we can write 1 over 2 as 2 to the negative 1 and to the power negative 3. And this will be basically from earlier properties that we discussed. It is 2 to the power negative 1 times negative 3. Multiplication of two negative terms is a positive term, so negative 1 times negative 3 is equal to positive 3. So the result is 2 to the power 3. Now, as a sixth property, now consider a to the power x divided by a to the power y. We can express this term on the left as a, the common base, to the power x minus y. All right. So just to show this as an example, 5 to the power 3 divided by 5 to the power 2 is equal to 5 to the power 3 minus 2. And this is equal to 3 minus 2 is equal to 1. So 5 to the power 1, which is simply 5. Alternatively, if you really want to go into, break it down, we have two other options. So we have 5 to the power 3 multiply by, instead of divided by 5 over 2, 1 over 5 over 2 separate. 5 over 2 is, remember, 5 to the power negative 2. So we have 5 to the power 3 times 5 to the negative 2. So sum these exponents because we have a common base. So which is equal to 5 to the power 3 minus 2, which is equal to 5 to the power 1, or is equal to 5. An alternative way, a very explicit way of writing this is 5 to the power 3 is basically 5 times 5 times 5. 5 to the power 2 is in the denominator 5 times 5. So 5 times 5 appears both in the numerator and denominator. So we can cancel these 5 times 5 terms from the numerator and denominator. So this will leave us with only 5 term that is remaining in the numerator, which is 5 or 5 to the power 1, etc. I didn't show it, write it here, but you can easily, show if you want to really explicitly show this, you can write it as such. So property 7 is a over b to the power x is equal to a to the power x divided by b to the power x. So basically this exponent operates both on the numerator and also the denominator. So let's show an example. Consider that we have 4 over 2 to the power 2. So we operate this exponent on both terms in the numerator and denominator. So this is equal to 4 squared divided by 2 squared. We can further simplify this. 4 squared is 16, 2 squared is 4. So 16 by 4 is basically 4. Now let's go over some examples of algebraic simplifications. Here, consider that we have an term which is x cubed minus x squared divided by x. We can write the numerator considering that we have common term of x. So we can write the numerator as x multiplied by x squared minus x. And we have also x in the denominator, meaning that we can cancel x from the numerator and the denominator, and we are left with x squared minus x. You can write this x squared minus x if you want to write it also using the common term x. You can write it as x times x in the parentheses x minus 1. So it's basically the same expression. As the second example, now consider that we have square root of 5 divided by 3 plus 7 over 2. Then we can combine these terms into a single term. Here we have different denominators, so we need to form a common denominator, meaning that we need to multiply the first term on the left by 2 and the second term on the left by 3, as you can see here on this right-hand side. So this means that we have a square root of 5 times 2 divided by 3 times 2. Remember, we multiply both the numerator and the denominator with the same number, plus 7 times 3 divided by 2 times 3. We can show that the denominators are now identical. 3 times 2 is 6, 2 times 3 is 6. So we have a single denominator, which we can express as such. And the numerators are, the first term in the numerator is 2 times square root of 5 plus 7 times 3, which is 21. All right, so this is the second example. Now, as a third example, now consider that we have x squared plus 2 to the power 2. So now our exponential function is such. Our base is this function, which is x squared plus 2. Since this is square, we can write it as multiplication of x squared plus 2 times x squared plus 2. Basically, we can multiply the base by itself, since it's second power, which is basically x squared plus 2 times x squared plus 2. Then we conduct this multiplication. So we have x squared multiplied by x squared, which is x to the power 4. Then the second multiplication is x squared times 2, which is plus, because all of the signs are positive, so plus 2x squared. Then multiply the second term here with this first term in this parenthesis, 2x squared here. And lastly, just multiply 2 by 2, which is 4. Just simplify a little bit further. There should be an x squared, x to the power 4 here. I don't know why it disappeared, but this x to the power 4, please write it in your notes. There is x to the power 4 here. Then 2x squared plus 2x squared, we can merge them as 4x squared plus 4. So we have x to the power 4 plus 4x squared plus 4. So this is the final answer for this problem. Well, that's all for this video. Thank you, and I'll see you in the next video.